Hi, welcome to my channel. My name is Magnus, and today we're going to talk about what sort of open servers do I actually use myself. And I use three different types of open servers, and all are based on the HP DL360 Gen 10. So I don't use the DL380 Gen 10, and the difference between the 360 and 380 is more or less that the 360 is only one rack unit, so you cannot have as many hard drives or disk storage. And we don't really need storage in a gateway or a VSX gateway. We only need interfaces, memory, and some nice CPUs. And it's the same type of CPUs for the 360 and 380, so there's no difference there as well. You are able to have quite a lot of interfaces in the 360. I believe that you can have, is it 6 interfaces in total with riser card and so on? I don't know if you can have more in the 380. Someone can correct me if I'm wrong there, but I want to save the rack space because the rack space is quite valuable, and I have no need for a lot of disk in a gateway or VSX gateway. So in general, if I decide to go for like an 8-core machine, I always do 2 CPUs. And the reason for this is, well, then I can have a CPU with higher clock speed. Because my goal is to buy the nicest clock speed that is, well, price efficient. So I always go for the Xeon Gold, at least now in 2021, and I have been doing that for the last few years. I don't see the need to go for the Platinum CPU because they're quite a lot more expensive and you don't gain so much more performance. And because I'm running VSX, I'm able to scale out my systems linearly. So I can add 1, 2, 3 more nodes in the same cluster and just spread out the load evenly. And this is of course only possible if you're able to spread out your load by dividing it up on different VSS. But that's a different topic. That's for the VSX topic, so to say. But in general, I don't need so much cores because I don't have one single firewall that is using like 40 gigs. I have a lot of small firewalls or virtual firewalls on the box that maybe uses a few hundred megs or 1 to 2 gig each. And then I can spread them out on multiple boxes so I can have lower core count on my servers. I'm using 8-core licenses in most cases. And this allows me to not buy the XL or XXL licenses for like IPS application control and so on. So more or less what you need to do when you're building open servers, you need to calculate not the performance to weight ratio, but the performance to price ratio. Like where is it most efficient to go for more boxes or higher core counts? And this is nothing that I can really help you with because it depends on like rack space. It depends on what sort of traffic that you have. What sort of traffic requires a lot of blades and what sort of traffic only requires like throughput when it comes to like firewall or IPS. That is not super intensive on the CPU core. And I try to avoid smaller than 8 cores for open servers because there is like in the small and medium business or small size boxes, it's more efficient to run like appliance boxes. I normally don't say that, but normally it's more efficient to run appliance boxes. Then you have a mid segment where I personally think it's cheaper, better, more efficient to run open servers. And that's between like 8 and I think it's 24 core licenses. And after 24 core licenses, well, then you need to use like Maestro and so on to actually get that performance. And then you need to use appliances. So it's in this mid segment that I use open servers. And well, that's 95% of my install base that is open servers. And in most cases, I use 8-core boxes. And I try to use similar boxes everywhere. So it's easy to, well, to connect them in the data center because I have, let's say I have 20 of these boxes. I want all of them to look exactly the same so I can move them around or I can use them in different cluster. Let's say that I have a cluster and we have a customer that suddenly like, where, yeah, we want double the performance. Okay, but if it has gone, let's say 2 years, maybe you cannot buy the same hardware. Then I can strip one cluster and move it and combine the clusters together because I have the same hardware. That's a different topic maybe, but the point is when I'm running VSX with open servers, I want to have the same type of hardware everywhere so I can scale the clusters linearly, because then I can more or less add a second node or a third node or a fourth node to a VSX cluster and move that customer to that specific node and more or less grant him all the performance from the 8 core. So this is the reason why I try to spec my servers the same way. I want them to look the same way because it's easier for the field engineers and so on to rack the servers in the data center and connect them to the switches. So what did I actually select for my open servers? Well, I'm using the Xeon Gold 5222, and that's a 3.8 gigahertz 4-core CPU. So I have 2 of these, so I have 8 cores. So I don't use the hyperthreading because the hyperthreading cores are, well, slower. I think it's like 15 or 20% slower than real cores. So you can argue like this is a 16-core box, and I would say no, this is an 8-core box, and I would use it with an 8-core license, and I will turn off the hyperthreading. If I need a 16-core box, I buy 16 cores. More or less, I buy 2 8-core CPUs, and then I have a 16-core box. Hyperthreading wasn't able to, or wasn't supported to use for open servers before, but it now is in later software, but the hyperthreading cores are slower than real cores. Then you see here I have quite a lot of memory maybe for a gateway. So I have 192 gigs of RAM in a gateway. And the reason for this is because I'm running VSX, it using more memory because it has more connection tables. And Checkpoint has quite a lot of memory leaks, and I don't like to reboot my stuff because of memory leaks, and I don't like to have problems because of memory leaks. I think putting the amount of memory is a cheap way to not have issues. I would not buy an open servers below 64 gigs of RAM. I would always fill up all the RAM slots, and the reason for this is to get the maximum performance out of the box, because then you can use more bus speeds. If Checkpoint is really using that, I don't think so, but that's like the best practice when you're buying servers that you want maximum performance of, to spec them out and fill up all the slots. It's a bad practice to do that on virtualization servers because then you have no upgrade path without changing all the memory slots. But I'm planning to change these boxes every 3 to 5 years depending on how they perform and what is available. And that's also a benefit of running open servers. You can move the license from one server to another. It just needs to have the same core count, and it needs to be available on the hardware compatibility list. Then you see here, I'm using SSD disks, and I don't like mechanical disk. I don't even know if it's possible to buy mechanical disk to this, but SSD is the way to go. It's not much write intensive and so on. It only writes to the disk if it doesn't reach its man server or log server. And I think 480 gig is enough. I don't like to cheap out of it and buy like the even smaller disk. I don't know how small disks there are to buy, but this allows me to have like 150 gig root position and still have snapshots and a fair amount of log on the server. And of course I'm running it in RAID 1, because RAID 0, then you use both the disk and have no redundancy. If you're using RAID 1, you have redundancy, and then you're able to change the disk if you want. Then I'm running a normal 10 gig ports, and these 10 gig ports I use for the sync interfaces. So yes, I have only one NIC for sync, so if the NIC goes down, both my sync cables go down, because I use both of the sync cables. I mean, it's a 2-port NIC, and I connect them to 2 different type of leaf switches, so I have redundancy in the switch infrastructure, so to say. And then I need to have Razer card, and this is to be able to have the amount of interfaces in the boxes that I want to have. This is the controller, and this controller you need to check in the hardware compatibility list if the controller is supported. This one of course is, because this is my actual Checkpoint firewall that I'm using and have a bunch of. And then I have 1 gig ports, and the reason why I want to have 1 gig ports is because we have not only ILO, I mean these boxes have out of band management interfaces, ILO, but I also want to have one interface for VS0. And I myself, I also have interfaces for what I call like VS access or customer access, and that's how I reach the customers located on these boxes. And then I send the traffic on the 25 gig NICs that we will talk about later. In general, I try to spec the servers with as many interfaces as they're fit, because it's cheaper to buy the interfaces when you buy the servers. It's also good to have the options. I mean, I want to have 10 gigs interface, I want to have 1 gig copper interfaces, and I want to have 25 gig interfaces for my production traffic. And this gives me the possibility to actually have this. Then you see here I have a quite fat power supply. And I would say like this, don't cheap out on the power supply, because these boxes are meant to be running fully loaded all the time. I mean, you want to have a lot of traffic in your network. Of course, you want them to be able to use this. Maybe this is overkill. I don't know. I don't care. It's not much price difference to go for the nicer power supplies in these boxes. And I think it's worth it. Then there are some how you want to have the support, and this is really depending on, do you have spare part yourself? How important is the boxes? Do you have multiple boxes? Are they redundant in themselves? And of course, if you build checkpoint clusters or checkpoint firewalls, you build them in clusters, so there's minimum 2. If you're building VSX clusters, you normally have 3 or 4. But in normal clusters, you have at least 2. This is of course true for VSX as well. And at the top here, we have a separate card, and this is to have 25 gig NICs. And you see here I have quantity 4, and this is because it's 2 different machines. So I have 2 of these cards for each server. This gives me 4 25 gig ports. So in total, this box, it has 4 25 gig ports and 2 10 gig ports and 4 1 gig copper interfaces. So this gives me a great number of interfaces. I have the possibility to connect it more or less how I want it. And keep in mind, this is in a DL360. So I have quite a lot of interfaces for a small box. And I think this is awesome. This is great. So in total, we have 4 interfaces. Maybe 4 interfaces is max for DL360. It's enough for me. And that's 4 interfaces, and each interfaces has multiple slots with interfaces. So this is my standard go-to box for VSX gateways when I want to have a lot of performance, but I'm not running so many blades. I'm only running like firewall and IPS on these boxes. And the reason why I go for an 8-core box is because it's cheaper licenses wise, and our price to performance is really nice on this type. And it depends on how much you purchase from Checkpoint, how much you purchase from HP, and what type of prices you can negotiate and how you actually use your boxes. For us, this is really good for most of our customers in our hosted environment. If we then go for like the high performance stuff, I mean, some customers or in some environments, you need more blades, more functions, higher throughput. Maybe you have one single customer, or you have one single department or one single function that needs like 5, 6, or maybe even 10 gigs of throughput in one box. And I'm running VSX, meaning I should be able to have multiple instances, multiple virtual firewalls on the same box. And if I only have 8 cores, and I want to run one virtual system that runs 5, 6, 7 gigs, I'm not able to have much more on that box. Because remember, if you want to run throughput above 3.5 gigs. This changes sometimes, but then you need to enable multi-queuing. And if you enable multi-queuing, that means on an 8-core box, you take minimum 2 cores that is only assigned to handle the interfaces. That leaves you 6 cores to handle the traffic. And normal firewall and so on, it's no issue. But if you're running a lot of blades, this requires more cores. So for this purpose, we made like a more nice box, a fatter box. It's more or less the same box. The only difference on this box is that we're running another CPU. So we have 2 of this Gold 6250, and that's a 3.9 gigahertz CPU with 8 core each. And you see here, it draws a bit more performance. So it's 185 watts for one CPU, and the other one was 105. And this is why it's important to have like the nicer power supplies. But other than that, we spec them the same way. So we have the same number of 10 gigs interfaces, we have the same number of 1 gig interfaces. It just, this was purchased 1 year later. So there are like version 2 or whatever of the interfaces. It's important that you have it on the hardware compatibility list. You can only buy stuff that is on the hardware compatibility list. Checkpoint doesn't care about what CPU or what memory or what disk you have, but they care about what sort of server it is, like the DL360, DL380, G10, etc. What sort of RAID card it is, that's this one. And what sort of interfaces. That's the important part. The other part, how fast the memory is in, how fast the CPU on is on, that's up to you. And the reason why I picked these specific CPUs is because the money to performance ratio. This is how high CPU I want to go for a 16 core without it hurting the wallet or business case in my case too much. Because I'm still planning to run, let's say 10 customers on a cluster like this, but I'm planning to run customers that requires higher throughput in one single VS, one single virtual firewall, compared to this one. I'm still running the same amount of customers, but these customers doesn't require the same amount of throughput. If a customer want to upgrade, you can do 2 things. Either you have enough, or you can do more things, but let's say 2 things. Either you add 1 extra node to the VSX cluster and dedicate that VS, that virtual system, to that specific node. Then you have 8 core or 6 cores because we take 2 for multi-queuing. Or you can move to a different cluster. In our case, we move them to a different cluster if we have the possibility, because that requires some short downtime. Changing the virtual cores and so on, it doesn't really require any downtime, especially if you're running from R8030, then you can change the cores. It came in kernel 3.10, so kernel 3.10 has some nice features. And if you're running a 16 core box, or at least we, then we actually assign 4 cores for the multi-queuing, because we want to be able to run higher throughput. If you want to be able to run higher throughput, you need to assign more cores for the NICs, because each core can manage like 3.54 gigs of traffic. So if you want to run more than that, you need to assign more cores. And that's why we have 4 cores assigned on the interfaces when it comes to our 16 core boxes. We actually have 1 or 2 clusters that has 24 or 32 cores machines as well. They're quite nice. And they are spec'd the same way. We just changing the CPU, and we always try to take the CPU with the highest clock count on the gold spectrum, not the platinum spectrum, that we can get. And I don't know if this is scientifically proven or whatever, but our experience is that the clock speed on the CPU really matters. So we intentionally, due to the type of traffic that we have, we try to have lower cores based on price, based on the type of traffic that we have, and just have higher clock speed. It's not worth it to buy like a 2.4 gigahertz CPU or whatever. I mean, the server itself is not really expensive. I mean, it can cost money, but it's not the majority of money when it comes to the checkpoint cluster that you're going to install. The majority of money is regarding the licenses. The server is a small piece of this. So don't cheap out on the servers. Make sure to buy like the fattest server that you can buy for the core amount that you want. And for us, this is the 16 core version, and this is the 8 core version. And I mentioned in the beginning that I have 3 different types. And the third type of server that we're using, well, that's just the smaller one. We have a 4 core one that we use for ILO, for management, etc. And the only difference on this one is that we don't use the 25 gig NICs on this, because this is not meant to handle a lot of traffic. It's only meant to give access for different things, for us, management access. So we have 10 gig cards in them, multiple 10 gig cards here, and we have 1 gig cards. And we only remove one of the CPUs. And when you remove one of the CPUs, well, we skip half of the memories. So if we want to upgrade this one, we could, I don't think we will, just buy one of these CPUs and 6 of this memory. Then we have an 8 core box again. And they are very similar then. I mean, we wouldn't have the 25 gig NICs, so we would have need to change that as well. But we don't buy a different brand, we don't buy a different type of CPU or anything like that. I don't even know if there are 2 core CPUs that is Xeon Gold. So we're using this one. But as I said, this box is not really meant to press a lot of traffic. It's only meant to give like access. I mean, maybe it's a few hundred megs of traffic in these boxes. So it's the 8 core and the 16 core boxes that we press a lot of traffic in, and that is nice to work with. So I think this is it for this video. If you have any questions regarding why, etc., I can try to answer it. But the real calculation that you need to do, it depends on your prices. I mean, how expensive are the servers if you buy them? How much do you pay for the licenses? Do you get more discount on specific licenses? So we have a really good price on 8 core boxes, and that's why we use them a lot. We are moving more and more to 16 cores. And the reason why we're moving to 16 cores is because people are requiring more throughput. They are ordering higher bandwidth. So instead of ordering 1 gigs, they want to ordering 5 gig, 6 gig, 10 gig. And then we need bigger boxes because we still want to have a few customers in inbox. So thank you for watching, and I hope to see you in the next one. Take care.